My name is Mark Struberg. I'm from Vienna. I'm a Apache Software Foundation member since quite a few years, and I'm employed at the company in Vienna. And my day job is usually I get deployed to customers and help them getting their stuff done. And my personal definition of done is to have an application running in production for at least 3 months, and the users are happy, not the customers, because those are the people who pay me, but the users, the people who really work with this application, they have to be happy and satisfied. It's sometimes a little bit different. So I'm not a consultant in the sense that I just go to customers, talk about things, and then I'm off the scene again, but I really into doing those things. And in the last few years, I've seen quite a few microservice applications. And so kind of 7 out of 10 applications you see nowadays, they start as microservices. So it's kind of trending. Probably we've reached the peak microservice already, but it's a thing. And the question is why that, especially in Europe. I'm not quite sure if how it is in the US, but in Europe it's really trending. And my interpretation is that we have a lot of conferences where people, every second talk was about microservices and raving, and if you don't do microservices, you do it wrong, and you should throw away your old application. And then we have computer magazine articles about microservices, and it's so cool, it's so great. It's the best ever, and if you don't do microservices, you do it wrong. So this reminds me a little bit about the old story. You probably know this. If you have a hammer, every problem seems to be a nail. And in German, there is an even better proverb. Translating to the English people, for each screw there is a hammer which fits, and if you're a little bit a Tim Taylor and into homeworking and you imagine a wooden board and a screw and a hammer, then you quickly figure that it's not that a good idea. So the screw will get noodled, it will not hold in the wood will get grained, and your finger will end up being blue because you hit your finger with the hammer and not the screw. So how should it be? Use the right tool for the right job. And the question now is microservices the right tool for every job? As many conference talks make us believe, or want to make us believe, or computer magazine articles. Well, in my opinion, and I've been in the IT since, and in the industry, working in the industry since the early 90s, there have always been such kind of hypes and buzzes. And they are the industry needs this, we need to sell our services, we want to do new things, we want to try out new things. But if we are really honest to ourselves, then in a lot of cases it doesn't deliver. So there is this kind of hype cycle, and let's go just back a few years. What hypes did we have in the last few years? Cloud. Would you use cloud for every project? I mean, if you have kind of Netflix and you kind of in the Christmas Eve, you have 1,000 times the traffic, like on some random Tuesday morning, then it's probably a good idea to do cloud, because they can, if they need the traffic, if they have kind of the customers, then they scale up the servers, and if Christmas is over, they kind of shut them down again. And they don't need to pay for them, because they don't use them. And they don't need, if they would host their own operating system, well, then they would have the need for 10,000 boxes. So they just rent a few for kind of those peak things, those peak hours, and then they shut them down again. Really good use case. If you are an insurance company, for example, with 1,000 employees, and they enter your office at 7 in the morning on Monday, and they leave the office in the afternoon at 5 o'clock, and you have this Monday to Friday, 52 seconds a year, 52 weeks a year, well, then you know exactly what your traffic is. It's exact the same traffic every day. There is no peak hours. I mean, it's kind of straight. You don't need scaling that much, because you have your 4 boxes and they easily deliver the payload and the load on the systems. It's enough. You don't need to scale up for 1,000 servers or so dynamically. So there are other reasons why you probably want to do cloud. For example, if you're really smallish, but for some cases it's not that a good fit. What's the next? So messages for some problems a good fit, know exactly what the problem is, and for others it's completely. So usually it's an 80-20 rule. What is the next hype? Let's go back in the hype cycles. What was before that? Big data. I talked yesterday with Owen and I told him a nice thing. In my opinion, or my experience, 95% of all the big data installations we had seen over the last 4 or 5 years are completely nonsense. People just said, oh, we have 2 million customers. It's so many customers. We need big data. Well, 2 million customers is a hell of a lot, but it's nowhere near big data. So just kind of restore your production database to some other box. You have tested your backup strategy and restore strategy, and you can create temporary indexes, and every relational database can easily handle those things. Now, there is a nice use case which I want to kind of give you that so that it doesn't appear that big data is complete nonsense. Colleagues of mine did for a Krankenhausverbund, which is a bunch of hospitals working together, and you have a computer tomography scans, you have magnetic resonance scans, heart EKGs, and all those files are between 50 megabytes and a gig, and you have a few hundreds of them a day, which makes a few hundred terabytes a year, and you need about 5 petabytes of disk space. So try to purchase a box with 5 petabytes of disk. It's not possible. So what we did is just purchase 100 cheapish servers. Back then they were about 5,000 to 6,000 euros. 16 3.5-inch 8 terabyte disks, and install Apache Hadoop on it. So you had about 14 petabytes of raw storage, and via the replication you of course lose something. So you had about 4.5 petabytes of net storage which you could use. And then you have 100 boxes, each CPU core 16 threads each. And the university is using those 1,600 cores to do oncologic research. They do cancer algorithm on those data. So they can use the disk from HDFS, and they can use all the 1,600 CPU cores for doing cancer research on those boxes. And that's a really nice use case for Hadoop. So for 95% of the big companies which purchased and installed some big data or Hadoop installation, it's completely nonsense. But there are really good use cases where it's a perfect fit. What else do we have? NoSQL. Did NoSQL back in 2011 or so. All the magazines wrote, NoSQL will replace standard relational databases. Did this happen? I've not seen this happen. The reality is, relational databases are still around all over. But does this make NoSQL useless? No, definitely not, and you're using NoSQL every day. The domain name system, DNS, is kind of a NoSQL database. LDAP is basically a distributed NoSQL database. And there are, if you're kind of a mobile phone operator and you need to store billions of connection informations each week, then of course using Apache Cassandra is perfect. But for a lot of business applications, it just doesn't make any sense to replace your relational database. So same rule applies, 80-20 or even less. And my prediction is, well, with microservices, it's probably the same. Know your weapons, know your problems, and know when a specific tool is good for a specific problem and which downsides it also brings. Because there is always a trade-off. Every technical tool you use has benefits, but also trade-offs. And it's not just about tools, it's about kind of basic principles you apply to a problem. So what about microservices? When does it end, the talk, exactly? Katrin? At 4, okay. So just for getting me mentally set up. So what about microservices? If microservices are the answer, what was the problem? Because everybody yells, you can solve it with microservices, go microservices, but what to solve? And usually people have monoliths, and this is a problem. Because most of the times people have badly designed and kind of historic, naturally grown monoliths, which are inherently kind of Well, people over the time, over the many years, they get maintained. They add some parts here and some parts there. They have very kind of not really a clear design. So pieces got added all over the place. So you have interdependencies all over the place. I mean, probably most of you know or have seen badly designed big monoliths, right? Who has not? Is into academics probably. They are also not easy to scale, not in a technical sense, because technically you just drop in a new node and fire it up and you're done. But in a business sense, if kind of your company acquires some other company and you want to grow your business, well, adding this business to your monolith is sometimes not easy because it has no clear structure. It's not that you can just add another module and be done, and it clearly interacts with the other parts. But most of the times you kind of have to patch pieces here and there and kind of add something to the customer and add something to the billing and whatever, because those monoliths are usually bad designed and have no clear design. It's also hard to roll out. Also not in a technical sense, because in a technical sense, a rollout is dropping a EAR file to a server, restarting the server, and the rollout is done. But for me personally, a rollout means I have an old functionality, it works in production. And my target is to have the old functionality plus the new functionality in production, without trashing the data, having all running, having guaranteed that it operates. And this is what I understand with rollout. It's not just starting the engine and, well, sometimes the operation team say, oh, I've restarted the application. Well, it didn't even react on my clicks. So, and with this, with monoliths, you have the problem that you add some new functionality over there, and you use the leg and the wheel in the left down corner. So you can't be sure that it still works because you didn't touch your code locally in this module, but it's all over the place. And guaranteeing that the functionality still works in a monolith is tons of work, because your changes are not applied to one single module, but they are kind of inherently affect all the system. So monoliths, if they're bad designed or kind of historically grown, are really hard to handle usually. So the solution, microservices. Let's find out what a microservice is. Let's go to Google, and this is just the first link which pops up, and this is from SmartBear. It's just a random link. There is no clear definition what a microservice is. Doesn't exist. Still now the microservices have been around for now 5 years or so. But this comes really close to what most people understand. So essentially microservice architecture, so whoever claims microservices is not an architecture can argue with SmartBear, is a method of developing software applications as a suite of independently deployable small modular systems. So your microservice application is kind of the whole thing. You design the whole thing as one suite of smallish applications, but your goal is to have the whole business stuff, in which each service runs in a unique process. So they're usually started in their own virtual machine, on their own Docker instance or Kubernetes instance or whatever, and communicate through each other, communicate through a well-defined lightweight mechanism with each other. So most of the times this is HTTP plus JSON. People say REST, but actually most of the time they don't do REST, because REST means resource-oriented, treating something as resource. And as about 95% or even more, what I've seen in reality is they just use HTTP plus JSON, but imperative. Do this, do that. It's like remote procedure calls over HTTP plus JSON. It had nothing to do with REST from the real understanding of what REST is. And Roy is not here this year, but, well, you could talk with him about this. To serve a business goal. So again, the whole application is one business goal. Let's look at the single parts over there. How big is a microservice? Well, it should be micro. What is there? What was it? Method of developing software suite of independent deploying small modular services. I mean, this is the name, what gives the name to this whole architecture, microservices. How small is it? How do I measure it? How would you measure micro? Any ideas? Code size, number of classes, complexity, binary size. What do we take as microservices? And to give you some feedback, let's just look at the hard facts. Most of the microservices I've seen are around 80 to 120 megabytes. That's actually huge. Yeah? So if you go to the Spring generator, the Spring Boot generator, and click a few things, then you end up with 80 megabytes of a microservice. Yeah, that's the point. Okay, you spoiled it. A complete Apache Tommy, which is a complete Java Enterprise application server, has 35 MB. So Java Enterprise is dead, and it's so fat and so ugly. Of course, old application servers in the old days, like old kind of, I don't say names, but you know, the big irons, they have been in the gigabyte range. But those times a long time past. It's not true anymore. I mean, what's JBoss Wildflower has about 120 megabytes, Glassfish 150, Tommy is really small, 35. The full profile of Tommy has about 45 megabytes. And we have Apache Microwave, we've talked about it a little bit yesterday and showcased it. It has 9 megabytes. And this is CDI plus Chuck's RS. Plus JSON-P, JSON binding, and Log4j, and so the core technologies which make the MicroProfile 2.0 platform. Well, and this is what I call, so even if you bundle your whole application to it, it's probably 10 megabytes or so. This is rather micro, but actually I wouldn't even measure it in code size, in binary size, but I would measure it in complexity. And just as we started with spoiling already, I would not go for really being micro. I would rather not cut your business too smallish, but rather largish. I explain this later why. Okay, let's go next. They should be independent services. Are microservices really independent? Yeah, in theory. So one is. They are independently deployable, yeah, but it doesn't mean that they are, from a business aspect, independent. Of course, if you have a network boundary in between, then it happens less frequently that people just add functionality just over there and over there and over there. Because you have network boundary in the middle. So it's less common, and it's most of the times a different repository and so on. So it's less common that people just commit code to some foreign module which they don't own or don't belong to, and it's not their business, they don't understand what they're doing. On the other hand, it's possible, and often if you have kind of, it also depends. People always compare this with Netflix. And Netflix, the business model of Netflix is completely simple, dead simple. They have one use case, basically. Of course, in the back office, they have more. And the most complex part of NetBeans is not the content delivery. It's the content provision and the payment calculation, the clearing with the content providers. Because those are really complex contracts. And this is what a lot of business is into, and a lot of complexity, but the actual delivery of Netflix is that simple. It's just a hell lot. It's gigabytes per second with 100 millions of customers at the same time. That's technically huge, but from a business aspect, it's so much more simple than an insurance company, a bank, or whatever, because they have 800 dialogues and 500 different use cases, which you need to tackle independently. So the business use cases of most of the applications, mostly to boring applications, like old classic applications, most of those customers have much more complicated business use cases than Netflix. And in these business use cases, you often have the problem that the business use case has cross-links and has dependencies on each other. And if the business you need to kind of implement has interdependencies, well, then you have to implement them somehow. There is no way around. It's not technically possible. So the next thing is, what about versioning? MicroService is cool, and if you do a new version, the good news is that if you kind of want to improve the customer part, you only touch the customer part. So this argument really delivers. You are localized, you are working in your local module. The problem is once you need to kind of add additional features, but some stuff is still used by another microservice. So you have 150 of those microservices running, and some parts of your customer microservice are still used by the billing or whatever. So you can't remove it without also having to kind of redeploy and re-update your billing or whatever. You don't even know what's using your stuff most of the times, and that's one of the problems. So you need to add a new version. So what can you do? You can kind of create a new REST endpoint with version 2, or you can add a parameter, and if the parameter is null, it got called from the old version, and if it's filled, then you probably have the new. But what if you, for the general data protection regulation, you have to remove functionality? Like, for example, having to remove the functionality that you can serve and access historic data of a customer. This is probably required by law. So you can't just leave it and until nobody uses it anymore, you have to switch it off. That's kind of problematic. And the other thing is, writing software or writing microservices is completely easy. Maintaining is a little bit harder, because if you have a microservice, and we had the longest one is kind of now 3 years, and they get into real troubles because it's easy to add new functionality. It's really hard to get rid of old functionality. So maintenance doesn't only mean to add new features. It also means to get rid of old unused features. So how do you detect? You have 150 microservices running in the cloud somewhere. How do you detect which microservice is actually unused? Any ideas? Logging, network traffic analysis. Yeah, funny things happened. And let it blow up. Yeah, it works. It's yeah, most of the time. No, a few funny stories. So, observing the network traffic via logging or via kind of a sniffer or something like that, or Istio mesh, works rather wellish, but only if the functions you want to remove are really frequently used. So we had the lovely use case that the annual end of year calculation got removed. Well, it had no traffic the whole year. And you got me? And the other thing was that the error. So there was a kind of Geizhals is in Germany. Yeah, I think this was a Heise. Or take some other example. Some service and from external vendor, and you access this service, and you have a fallback case. So if the external vendor service is not available, you kind of switch back and show your own recommendations. So your own recommendation system, this fallback solution, will not get hit for a month. But once the external vendor is down, well, then you need it. Yes, too bad we removed this because we didn't see any traffic for months. So that code elimination is really a really problematic topic, because you essentially have to go through all the microservices. You can do the first guess, network traffic analysis, log analysis, and stuff like that. But eventually you have to go to all the other microservices, and you don't even know them because they're done in a different operation in a different country or whatever. And you have go through them. Then you can be sure. How do you do this in a monolith? I go on the method find usage. That's it. Job done. We have reflections sometimes, but most of the times the IDEs are really good in all this stuff. So having a monolith, and they could be externally used, but then you have a REST endpoint or something like that. But if it's just Java code, find usage, and you're done. And you're kind of 99.999% done. So this part is much easier in a monolith and really hard in a microservice. Independent data is also cool. What does it mean? So a recommendation or kind of a basic rule is if you have a service, it has its own data. If you have a customer service, it has its own data. If you have a billing service, it has its own data, means its own database. Okay? That's really nice, and it's a real benefit for kind of microservices, because often in biggish monolithic applications, your database is just like spaghetti. You try to grab one table and then you have cross queries and kind of links and all over the place. This isn't a must, but it often happens in monoliths. What you should do is kind of always only reference the main entity of a foreign domain. And most of the times that's okay. But if you have a kind of links from the medical system to some cross table, which you only technically use, then something should appear to you that it's wrong. The other argument is independent programming languages and frameworks. That's true in theory, and it works really well if you have HTTP and JSON as transport layer. If you go into kind of messaging, which is also, because you don't always, the traffic is only defined to be lightweight. So it could be HTTP plus JSON, but it could also be messaging, like Apache Kafka. But then, I'm not quite sure, a colleague of mine is a lot into Haskell. I'm not quite sure if there is a Haskell client for Kafka. I don't know. But most of the times you're pretty safe if you're in Java, or some JVM language at least. And the other thing with messaging is that basically if you do messaging, you're actually, from the architectural point, back to kind of having an enterprise service bus again. But you replaced your old cruddy XML service bus with messaging service bus. But it's basically the same from an architectural style. But at least it works a lot better than the old ASBs. And the other thing is data consistency and transactions. If you have a customer service, one database, one service, and you have an address service, one database, one table, one service. This pattern is called entity service. So whenever you hear it, run. But I've seen this, and now what happens? I'm kind of the user CRM service, and I create a customer, one call. And then I create address 1, second call. And then I want to create address 2, boom, network failure, whatever, blows up. So what do we have now? We have one customer and one address, but actually he has 3 addresses. Bad, we created trash data. And what happens in a monolith if you're properly set up, so if you're either using Spring or properly set up Java Enterprise, you have a transaction interceptor usually. Most of the people are not aware. I mean, you're the good guys or ladies, you know all this stuff, but still it's kind of, oh yeah, there was a transaction. Usually you don't take care. Because what happens? The outermost kind of transactional class, whether it's Spring or it's Java Enterprise, kind of looks, is there a transaction open? If no, I create one. I start a transaction. And then you can kind of nest all those service calls and call themselves and whatever. And on each layer, the check is the same. Is there a transaction open? Oh yeah, it's already open, so I do nothing. I'm completely transparent. And then the method goes down, does something in the database, updates the user, updates the addresses, and so on. And it goes back up. And on exactly that layer where you created or opened the transaction, you either commit it if there was no problem, so no exception got thrown, where the transaction got opened. On this layer, you either commit the transaction or you rolled it back if there was an exception happening. So if some colleagues didn't care, or if you yourself, happening to me as well, I didn't care as much as I should, and I did some stupid things, and while creating the address, I overlooked that there is a mandatory field and I didn't have it, and boom, exception is blowing up. What happens? A rollback. So all the stuff is rolled back. Your data is clean. Of course, your Your clients will complain that the application isn't properly working, but your application is clean. And again, depending on the business, for Netflix, they totally don't care. But if you're an insurance company or a leasing company like doing leasing for houses, so one damn entry in the database might represent a value of 10 millions of euros. So you better make sure it's really good data in the database and you don't trash your data. But it completely depends on your business case. Sometimes it's okay to not always have the correct state. Depends on the use case. But doing boring applications like I do, I'd rather have it on the safe side, and my number one priority is keeping the data safe. So, how do you do exception handling or failure handling, let's call it that way, in microservices? Anyone did program C? Low-level C? Yeah, okay. So how did this look like? You have one call to a method. It does something. And then you get a return value. And then you have kind of 20 lines of code for error handling and cleanup and doing rolling back or whatever. And in the microservice world, you have to do exactly the same for each and every method call outgoing. There is no, I don't know, do you know a better way? Yes.
We are currently migrating to some state machine stuff. There is a command, and then you persist it, and then you go step by step by step, and you could recover all the steps whenever it's
welcome back to the 60s, because this is the big change which happened in 1973. 1973, that called SQL database, relational databases, transactions got introduced, and since then, we are used to just doing stupid thing, and if it blows up, well, then it blows up, the data is safe. If not, then we are back to what we had to do, and I know all these banking applications written in COBOL, and they had exactly the same thing. For each table, they had two fields, a status and a substatus. And so if you create you have the user entry, you create the user. Then you store, I created the user. Status 1. Status 2 is, I'm about to create the addresses. And then the substatus is kind of a counter how many addresses you added. Okay? And you have to store this away with a transaction, with a go to a database, with committing every day or every single step. Because you did an external call, and then if something happens on your local side and you blow up and you do a rollback because of locally blowing up, then your status is gone. So you have to kind of, for every outbounding interaction you do, you have to properly commit your data and update the status in every damn table. This is possible, or you can go the message way. It's a completely different way of thinking, be aware. It's possible, you kind of use like a process engine, like Camunda or something like that, where kind of the process engine does the state tracking for you. But it's essentially the same. You have to do state tracking for every outgoing step. Because if you call multiple other services and something blows up, then you are in totally undefined state. You blow up, the external system blows up with some 404. You don't even have a clue whether the address got stored or not, because you don't get an information whether the storing did work in the database and only then the response blew up, or where it blew up before. You simply have no idea. Okay? So it's a little bit more complicated. Failure handling is really a huge part. Usually it's 80-20 again, 20% functional code, really productive code, 80% failure handling. Be aware of that. It's possible, it's great, but be aware. And so that was my recommendation, why I recommend to rather cut large-ish services, because inside your service, all the things you do inside your service, there you can still use commit rollback and automated transaction handling. But once you do a remote call, well, then you have to do state handling. You can also do, this is also a reason why a lot of those things, lately they fell on their knees, because you don't see this. It works great until you have the first problem. And then you kind of try to repair your data for weeks. So I saw many applications or many microservices which kind of, after 2 years, they completely rewrote their stuff and switched to messaging. So, okay, next one, because we're running out of time. Netflix does all that. Netflix doesn't do this because they don't need to. Their business is different. If they lose a transaction, who cares? What happens if you click on the play button and Netflix doesn't play? Nothing. Exactly nothing. Except that you will probably, after 2 minutes, you will kind of, what's going on? Press again. And if it still doesn't work, then you fridge a beer from the fridge. You grab a beer from the fridge and then you try it again, or you go to sleep. So, okay, giving up. So it's not important for them because nothing happens. You think about banking or insurance companies or medical applications. Yeah. Oh, my heart, pacemaker. Well, I had an error, so bloop. Probably not a good idea. Smallish other parts. The fallacies of distributed computing. We all heard this in university, and I just want to go. I mean, probably you know this. If not, read it up. I don't have enough time to explain them because you can write books about it. But the latency is 0. How much time does it take to make 100 million invocations to a Java method? 0. No, not 0, but kind of you are in the 100 milliseconds or 50 milliseconds area if you do this concurrently on 100 threads. How many seconds does it take to do 100 million HTTP JSON calls? Hours, many hours. So it's a slight difference. So don't do n+1 where you kind of iterate over a list of 1,000 entries and do service calls. It's a for loop in a service way. There you need an additional service method on your target where it kind of takes a list of IDs or whatever. So you have to you can't do it in a for loop anymore. Well, that's obvious. Once you hit it, then you wonder why this thing takes 5 minutes and then you change it. But yeah, it's... Anyway, I'll read this up if you didn't know it. That's really good. Testing is also funny because how can you test all those things? What I've seen so far is most of the clients have a big installation of basically duplicated the production to smallish boxes or virtual machines, but it's 1-to-1, 180 microservices or so. And then if you want to test your customer service update, well, then you deploy your customer service, your updated new customer service to this test installation. And if it's green, you can deploy it to production. That's great, except if the other team you don't know about at the same time updates the address service. And your test is just green because the address service also got updated. Or you get failures and you wonder what did I wrong, but actually you did nothing wrong, but someone else is concurrently testing on this hardware because not every developer is having, or you can't boot up 180 installations on Docker. It's not possible. So it's a bit complicated, and the communication overhead is quite largish also. The other thing you can do is locally mock away things. The smaller you cut your microservices, the kind of smaller you have to do your mocks. And then you have you have 180 services and every of them has a mock of user service. And kind of after a while, every demo of them behaves different of the mocks because it's not the reality, it's just the mocks. And they probably have been okay at the start, but over 2 years, they kind of diverged from the reality. So the mock doesn't reflect reality anymore. But you test against the mock, and in production it behaves completely different. You mock the hell out of your project. Capture and replay is okay to some degree. You have to replace things. What I've seen is Istio, an interesting project. It's but also has a lot of overhead. It's kind of for every microservice, for every box, you kind of have a proxy in the middle, which gets all your traffic, incoming, outcoming, and you can kind of like a fiber splitter, split it out, so you get your data directly from your production system kind of duplicated to your test box. And this is also sometimes really okay, but of course also has limitations. So what's the takeaway? Problems with monoliths can be solved by doing microservices. This promise is completely true, definitely. Sadly, the other thing around is also true. It's basically it's two sides of the same coin. And this has been forever since, because from the architectural style, the SOA, which we had in 2007, and microservices are exactly the same, except that they're using different tools, SOAP and XML, and now HTTP REST or messaging. But the architectural style is almost the same. Actually, even remote AGPs are the same architectural style. And did they work out well? For some problems, they do, but for others, not really. So there are a lot of takeaways for microservices. This knowledge we've built up in the last few years about microservices is not lost, because actually, you also have those problems in monoliths. Whenever you go out to a different system, for example, you have a document archive. And you scan in a document, too bad, the first is the birth certificate, the second page was some medical document, and you see this and say, oh, I should split this in the middle. And actually my one scan PDF is actually two PDFs. So how do you do it? You delete the original document, you split it, you upload the first site as a single PDF, and the second page is a single PDF, okay? So 3 steps. Okay, speak with me. I'm kind of the monolith, and I talk to my document archive. Okay, remove the original document. First step, upload the first page. Second step, upload the second page, a third document. Boom, inconsistent data. So whenever you go outside your own box, if you kind of leave your transaction guarantees behind, then you have to apply the same tricks than you do with microservices. And this also happens if you do a monolith. We can use circuit breakers. What is a circuit breaker for? It's really, really useful. Consider our document archive is down. And we use a lot of data from the document archive, like viewing contracts and whatever. So what happens if some thread, some user request clicks, oh, I want this document, like an elektronischer Akt, ELAC, is this a thing in Germany? So you kind of, basically almost every third page invokes something from the document archive. And you hit it, what happens? Oh, I do a request to your document archive. This is temporarily unavailable, but I don't kind of blow up immediately, but I kind of only blow up after a timeout of 5 minutes. So this thread is gone because it stuck in the request to the end server. Okay, and the second user clicks, and inside, in a minute, every 400 render threads you had on your box are blocked waiting for the document archive for 5 minutes. So how can this be solved? Via circuit breaker. In the Spring world, you use, I forgot the name, gosh. Anyway, basically it's a map. On every outgoing call, you remember, oh, I have this connection, I started it there. And then kind of if the next call goes out to the system, you say, oh, how many calls are open? And if you say, more than 5 calls open already, I look at the average times they are pending. And if this is too high, then I immediately throw, because before I even connect to the remote system. So if the threshold gets too high, I immediately blow up and throw a remote system busy exception or something like that. And the business code can then catch it. Of course, he can then present to the user, oh, the document archive is temporarily not unavailable, blah, blah, blah. But you don't block. It's not nice. It's a failure situation, but you don't block and get down your whole application at least. It's still working. They can do other stuff where they don't need documents. So XA is the same thing, and yes, you can do nicely built modular monoliths as well. And Axel Fontaine, the maintainer of Flyway database, did a nice talk, and you'll probably find it on Google, on YouTube. Questions?
Yeah. Is there any question you would like to ask now before we go into the break? No?
No questions, come on.
No questions? Okay, so then it's time for a coffee break now, and we will see each other again in 30 minutes. At 4:30 it will be starting here again. So thank you very much.